Hi all, welcome to Glass Workshop on Glass Academy. I am Ria Parikh. I am a design engineer in Saint Gobain Glass, India. So we will start with our session now. So first we will see the what are the basics of the glass, what are the different type of the glass, what are the different application of the glass, right? So before that, first we will see how glass is manufactured. What is the process that how the glass will be manufactured? What are the raw materials which are used to manufacture the glass? So as you can see on the screen, these are the main component. These are the main raw material which are used to manufacture the glass, uh, from which silica is a major contributor to the raw material of the glass, which is approximately 60%. The main component of the glass will be sand, and this mixed batch will be fed into the furnace. Okay, so you can see here on the screen, this is a setup how the glass will be manufactured, how glass will be moving in the different component. So you can see here, first all this raw material which I showed you earlier, it will be mixed thoroughly in the batch. It is called the batch. From the batch, it will go into the furnace where we have around 1600 degrees Celsius temperature, where all this raw material will be melted. After the furnace, it will go into the float bath. Now, float bath is a bath created using a tin. Tin is a denser material than the glass. So when the molten state of the molten glass will come into the float bath, it will float on the tin, right? And we will get a proper texture here in the float bath. After the float bath, it will go into annealing layer. In annealing layer, what will happen? The glass will start becoming semi-solid from the liquid form. So whatever thickness changes, whatever changes you want to do in the thickness or the width of the glass, whatever changes you want to do, right? That can be done here in the annealing layer. From the annealing layer, it will go into the cutting line where the ribbon of the glass can be cut in the desired sheet sizes. After the cutting line, it will go into P&D, packaging and dispatch. So now, what are the basic properties of the glass? So basic property of the glass, first density. The density of the glass is around 2.5. Refractive index is 1.5. Young modulus of the glass will be 70. Tensile strength will be 40. Compressive strength will be 1000. And coefficient of linear expansion would be 9 into 10 raised to minus 6. So these are the basic properties of the glass as a material. So now here you can see, as I mentioned earlier, that silica is a major component of the glass, and I also mentioned you how glass is manufactured, right? So you can see here the if you want to have the different substrate, different tinted glass, you have to add some more component in it. Like if you want a green substrate, green colored glass, you have to put iron into it. If you want bronze, you have to put iron and sulfur into it in the raw material. If you want gray glass, you have to add iron, selenium, and cobalt into it. And if you want a blue substrate, you have to add copper and cobalt into it, right? So this is how you add these particular raw material in the batch, and you can get whatever tinted glass you want. Now the end result of this process will be a glass. The you can see, right, there is a little greenness in the glass, right? It is because of the iron material. The sand which we use to manufacture the glass, it has some defect, we can say. So if you want to lower down that greenness in the glass, you have to use a proper sand which is having a low amount of iron, right? So you can see here, and I think you saw in the slide where I showed you the raw material of the glass. In that, it was written cullet. So cullet is nothing but a raw material. It is a broken pieces of the glass when the glass is manufactured, and some glass will break, right? So cullet is nothing but that broken pieces of the glass which you can reuse to manufacture the new raw sheet of the glass. So how this cullet will be helpful to you? First, you will have the saving in raw material. Second, your energy saving will be less, right? You need less energy to melt. then less carbon dioxide emission, and less waste in the landfill. So this was the manufacturing process of the glass. Now we will see what are the different type of the glass. So first we will talk about the substrate. So we can have clear, extra clear, green tinted, blue substrate, and bronze and gray tinted glass. And these are available in many thicknesses and standard sheet size for the further value addition like coating and processing, which we have to do on the this particular substrate. So now you can see here the second type is online coated and offline coated glass. So what is online coated and offline coated glass? You can see I showed you, right, that glass is manufactured in the furnace. If you want to do the coating itself in the furnace, itself in that particular line, it is called the online coating. And offline coating is what? You manufacture the substrate of the glass, you put it in the storage, and again, you do the coating on the glass offline. There is another plant called coater plant. You do the coating there. So that is called offline coating. And in online coating, you have the limitation of variation, you have the limitation of the product properties. But in offline coated, you can have so many advantages like you can have the different variety of the glass, you can have different properties on of the glass, you can have the high performance glass here in the offline coated product. So now the type according to the what we can say processed glass. So first we have the toughened glass. So toughened glass is what? It's a process of improving the material characteristic by heating to a high temperature. What you do when you have the raw glass, you again put it in the furnace, you again heat the glass and again you cool it down, right? This particular thing, when you do the cooling, it will be very sudden cooling because of the temperature difference, because of the difference in the stress, you can get a more stronger material. So if you can see here, if my tempered glass breaks, it will break into very small pieces like mentioned here in the slide. But if my glass is not toughened, if my glass is not processed, if it is normal annealed glass, it will break into very large pieces, which you can see here in the right side. So this is the thing which I mentioned, that how toughened glass will be manufactured. You do the processing on the raw glass. The same thing which I mentioned earlier. When you do the processing, some defect might be there if the processing is not proper, if the toughening is not done properly, like you can see here, roller wave or overall bow or edge lift. These are some of the defect which can be there in the glass if the heating or if the toughening process is not done properly. But nowadays, modern furnaces are better at controlling this. Distortion is visually disturbing, and which is something we do not want, right? So we need to be very careful when we are doing this kind of processing. Then we will move to heat strengthened glass. So heat strengthened glass is a similar process like tempering only, but the only thing is the difference in the cooling pattern. As I mentioned earlier, in the tempering, what we do the cooling suddenly. There will be a sudden cooling. But in heat strengthen, what will happen? The cooling will be gradual cooling. You heat the glass, and again when you cool it down, you cool it very gradually. Because of this particular thing, whatever stresses are generated in the particular glass will be different from the tempered glass, right? Because of that, the strength will also be different. So you can see here, if my heat strengthened glass breaks, it will break into a kind of island. Okay, it will create an island. If say there is a crack in between, that crack will go till the edge. It will not stop in between that particular crack. So you cannot have that. Okay, if my glass is there in the four-sided supported frame, it will not fall out of the frame unless and until you deliberately go and push it. Okay, so you can have the buffer time to change the glass if it is broken. Now we have the third type, which is laminated glass. So what is laminated glass? You put a PVB layer between the two glass, and you autoclave it. Autoclave is nothing but a kind of a oven process. You autoclave it. We can also call it in a normal language. We call it, I think, sandwich glass, right? There will be a PVB layer or EVA layer between two glasses. So the normal application, if I have to say, it is a windshield of your glass. That is my laminated glass. So if you might have seen that if that particular glass break, that glass pieces will not come on you. It will be stick to the PVB layer. So if you ask me that which one is the safest glass, tempered, HS or laminated, I will tell you that lamination glass is the safest glass. So you can see here the lamination layer can be, as I mentioned earlier, PVB or EVA. There is one more layer which is called Sentry. It is very strong when it comes to the laminating layer in between. And fourth type of glass we have insulated glass unit, IGU, or we can call it DGU also. So what happens here? You have two glasses and there will be a air gap in between or cavity in between. This can be filled with vacuum, which means air, or it can be filled with the gas. Okay. This is we can call it DGU or IGU. Then we have ceramic fritted or digital printed glass. You can do the enamel painting or ceramic printing on the glass here. Okay. So now we have different type of glass when it comes to innovation also. The first glasses are sage or dynamic glass. What happens here? You can actually control the tint and the solar factor of the glass. It can be changed according to your wish. You can do it with the app, you can do it with the remote, you can do it with the switch, or you can connect it with your BMS system of the building, and according to the sun movement, it will change the VLT and solar factor of the glass. We can call it a dynamic glass also. Okay. Now we have the switchable glass. We call it a Privalite. So what happens here? There are two variant here. Okay. As you can see on the screen, first my type is classic. In this particular type, what will happen when you switch it off? My particular glass will be opaque, but you can feel, okay, there is something behind the glass. But in Excel, what will happen when you switch it off? You cannot even feel that there is something behind the glass. The glass will become completely opaque. Okay. Now we have different application of the glass. So what are the different application of the glass? First, you can use it in the exterior, facade, or architectural glass, which you can see here nowadays. We can see many of the building are glass building only, right? Even in India, it has started. And in foreign country, you can see, I think almost all the building are of the glass. The second application would be railing. You can also use the glass in the railing. Third application we have is a skylight. You can use the glass on the skylight. Then we have the interior application. In interior application, we can have the wall paneling, or we can have the lift lobby, we can have the partition, interior partition, then we can have the signages, then column cladding, furniture, writable surfaces. These all are the application where glass can be used, which is a lacquered glass. You can call it a lacquered glass. Okay. Now we have again one more application, interior application, which is mirror. Glass is also used in the mirror. Okay. Then we have the shower cubicle. You can also use a glass in the shower cubicles. Again, interior application, one more application is kitchen shutter. You can also use a glass in the kitchen shutter. Okay. Now we have the fire safety glasses. Okay. So generally what happens, there are two type of fire safety in the building, passive fire protection and active fire protection. What happens in the active fire protection? You put a fire alarm system, or you put a fire extinguisher or hydrant, or you put a sprinkler system, or you can call the firefighters, right? But what happens in the passive fire protection? So passive fire protection uses a system that do not require any motion or action in order to work. Fire and smoke damper prevent the spread of flame and smoke through the ductwork of the facility. Firewall and barrier as well as the fire doors, if kept shut, help contain the fire to one specific location of the building, and the path marking system and the exit sign will continue to glow in the smoky condition, allowing people to navigate their way to the safety. Ultimately, what happens, this system compartmentalize a building into section to help contain and slow spread the fire and smoke. This is a main objective of ours, right? We need to contain the fire in one particular location so that the people can evacuate the building, right? But we need to ensure that that a building and the everyone inside will be completely protected, and it needs to have both passive and active fire protection system. Because if we have only passive fire protection, it is possible that we might not know that there is a fire. And if we have only active fire protection, only we will know, okay, there is a fire, but what to do now, right? So in fire safety in the building, when it comes to the passive fire protection, you can have the metal fire door or the glass fire door. So we'll talk about the glass fire door because we are talking about the glass as a material, right? So global standard of the fire resistant material, how do they classify the fire resistant material? Right, the first is E, which is integrity, then we have EW, and then we have EI. So first we will talk about what is E. So E is the integrity. It prevents the spread of the flame from fire site to non-fire site, and it will not collapse during the fire. You can see here, if there is a fire, it will allow the radiation, right? But it will prevent the spread of the flame. Okay, then we have EW, which is integrity and radiation control. So which will ensure integrity limits the radiation to the non-fire side. You will not have the radiation to the non-fire side till 1 meter of area. Then we have EI, which is integrity and thermal insulation. So what happens here? It will ensure that integrity completely insulation from the heat. There will not be any radiation on the non-fire side. So if I'll just come here again, just to explain, just to differentiate. So in E, what happens? You can see here, if there is a E type of fire resistant material used, you have to run. If there is a fire, you have to start running. If EW is there, you can walk. If there is a fire, you can start walking. And if there is EI, you can stand there. You can just stand and touch the glass. I'm just joking. You just have to. You can stand. You don't need to panic, right? Okay. So what are the products? So when it comes to the E-rated glass, there are two products, Keralite R and Pyroswiss. And these are the performance mentioned here and the application where you can use and the different type of the thickness. When it comes to the EW category, we have contra flame door and contra flame light. And third, we have EI rated glass. There is a product called contra flame structure. This will be EI rated glass. Again, this is the EI rated glass. Okay, so this was about the fire rated glass. Now we have the protect glasses. So what happens here? There are basically three types of the glass: attack resistant, bullet resistant, and blast resistant security glasses. So in attack resistant, this will give you the protection from the vandalism and the theft. Generally, people use it for the shop front and the premium showroom there where there is a possibility of the theft, right? And also when there are some high-end residential, high-end villa or farmhouse, people can use this particular glass. Then we have the bullet resistant security glass. So generally VIP people, then people who have the security threat, the politician, they might use this particular bullet proof glass. And also some high-end residential and hotels, they also use a bulletproof glass. Then we have the blast resistant glass. So protection from the terrorist attack, accidental blast, if there is an accidental blast in that particular case also the blast proof glass can sustain. where there is a nuclear installation or refinery. This might be the application for the blast-proof glass. Here we have mentioned that attack resistant security glass is classified security glass from P6B to P8B, and we are following European standard for it, EN 356. Then bullet resistant, it is classified security glass from BR1 to BR7 we can give, and SC1 and SC2. And it is certified according to the European standard EN 1063. And blast resistant glass, it is classified security glass from ER1 to ER4, and again it is classified under European standard of EN 13541. So I'll just revise again that what we saw: glass, different type of the glass according to the base, clear glass, tinted glass, right? Glass is according to the coating, online coated, offline coated, and glass according to the processing, SGU, DGU, DGU is IGU, normal. And again, it was fully tempered or toughened, heat strengthened, laminated, and ceramic fluted glass. This is what we saw, right? Other glasses which we saw was interior application, mirror and lacquered glass. Fire rated glass, we had 3 different type of the glass: integrity, radiation control, and insulation. And other type of advanced glass we saw: bulletproof, blast-proof, and attack resistant. And the third one was dynamic glass and switchable glass. So these are the glasses which we saw. These are the different glasses, different application of the glass. Okay. So now we have session 2, which is high performance glazing and different parameter of the glass. So you can see here, when you talk about the glass, there are different parameters in the glass which are basic parameter, which are basic necessity when you have to select a particular glass, right? First is VLT, which is, I'll come to what is VLT, what is SHGC, what is U value, what is internal reflection, what is external reflection. Now, criteria for the glass selection, again, when you have to select a glass for your building, what are the criteria you look into? First is safety, second is sustainability, and third is aesthetic, right? So first we will see the glass parameter. What are the glass parameters? The basic parameter of the glass. So we have first VLT. VLT is visible light transmission. You can also call it a visual light transmission. So it's a percentage of incident light transmitted. What percentage of light is coming inside? Okay. Light we measure in the lux. Okay. So what amount of light is coming inside through the particular glass is called the VLT of the glass, or a visible light transmission of the glass. So you can see here that the percentage transmission, whatever VLT you are getting through the glass, it will depend on the substrate of the glass, what substrate, what tint you are using, and also it will depend on the coating of the glass, that what particular coating you have used on the particular glass. Okay. So if I say that 35% is the VLT of my glass, so what does it mean? That it will allow 35% of the light which is transmitted on the glass. Say 100 lux is being incident on my glass. So from that 100 lux, 35 lux will come inside. Okay, that is a definition of the VLT. So I'll just elaborate more on particular this VLT parameter. Say as an architect or as a designer, we might have designed our building to look something like this. Okay, this is our vision, that this is how I want my building to look. But what happens? It ends up looking like this. First, we go with very high VLT of the glass, and then we put the blind. See, what I want you to understand that what is the main thing like you want to use the glass in the building. First, you want your building to look good aesthetically, right? And you want to connect with the outdoor. But what happens when you put the blind? When you put the blind, you kill the purpose of having the glass in the facade. You kill the connectivity with the outdoor, right? Blind not only ruin the outside connect of the occupant, but also aesthetic of your facade from outside. That is also main thing. So I think you want your building to look something like the left image, right? So I'll just come here. These are some more examples that what happens when you put the blind. Some more example. Okay, so what can we do? I'll just give you one example here. Look at the simulation of the room with 60% VLT and with 25% of VLT. You need only 300 to 500 lux to read comfortably. Okay, only 300 to 500. Now you can see in the 60% VLT, you have lux level around 7063, right, near to the computer screen. To comfortably work, you will need to shift to some distance, right? You have to go to some more distance than the window. But if you see here, for a class with 25% VLT, you have only some 396 to 400 lux near to the workplace, near to the computer screen, which can be easily occupied with any discomfort, right? You can sit there, you can sit at particular location because you are not having the glare. So you can see that, but light penetration, the depth of the light coming inside is same in both the places, both the places. Only the intensity is reduced, and that is what we want, right? So definitely now we need to revisit our idea of high VLT, right? High VLT is not 60%, 70%, 50%. High VLT is optimum VLT, right? You need optimum VLT, not very high, not very low. Because if you have high VLT, it will be called glare. If you have lower VLT, it will be like you will need a more of a artificial light, right? So this is a paradox. Okay, the paradox is that sometimes light is blinding. Excess of anything is bad, and glare is nothing but an excess of daylight. And we want daylight, but we do not want glare. Also, how we can address this particular glare problem? First, we can do with the active elimination. Second, we can do with the passive elimination. So active elimination is what? You can reduce the glare by putting blind or by putting shades or shutters. Passive elimination is what? You can do it with the design or choice of the material. You can actually select a material which will give you the optimum light, which will reduce your glare problem. So these are some of the example of the active elimination, that you can put the blind, or you can put the expensive shading devices, or you can reduce the glazing area. This is the active elimination of the glare. And second, like passive elimination of the glare is choice of material. You can actually go with the tinted glass or optimum VLT glass, which will absorb a large fraction of incoming solar radiation and glare, thereby reducing the solar heat gain coefficient, and also will give you the optimum VLT. And second is you can do the ceramic fitting. It will diffuse the light and eliminate the glare. Again, the third choice in the passive elimination is the dynamic glass, which I mentioned in the starting of our presentation, that what is a dynamic glass. You can actually change the tint of the glass based on your requirement. So that is an also option. And also you can go with the tinted glass, that you can actually go with a glass on green or a blue substrate, right? Now you might have the question that what if we are going with the tinted substrate? From inside, when we are trying to look outside, we can see that there is a greenish tint or a bluish tint, right? We won't be able to see properly. No, it won't be a case. You can see here, this is one example. This is one project, and where we have used KT440 product. Now KT440 product is a green color product. So from outside, definitely it will look green because you have selected a material green, right? But from inside, you can see it will look as clear as possible. You will not even feel that I have put the green substrate of the glass, right? Again, second example, you might think, what if we have the white interior? The reflection would be green or blue, whatever substrate we are using. But no, again, you can see KT440 product, green color product, but from inside you can see it is as clear as possible. Even if you have the white interior, the reflection won't be green or blue. So this was about the VLT. Now we have the solar factor. So solar energy incident on the glass is partly transmitted, as you can see here, partly reflected and balance absorbed. Okay, the solar energy absorbed is re-emitted inside and outside again. So the total solar heat gain is direct solar radiation plus solar radiation absorbed and re-emitted inside divided by the total heat which was being incident. This is known as a solar factor. Okay. So you can see here, which I have circle here, that is my total heat coming inside. Okay, you add both of the heat and divide it with the incident solar radiation here. You will get the solar factor. You will get the ratio which is called the solar factor or SHGC, solar heat gain coefficient, or G value. Then we have the U value. The third parameter of the class is U value. U value is what? You just have to remember the unit of U value, watt per square meter Kelvin. Then you can easily remember the definition of the U value, watt per square meter of Kelvin. What does it indicate? Total amount of heat coming inside because of 1 degree temperature difference through 1 square meter of glass area. That is my U value. Okay. Again, I will repeat. U value is total heat coming inside because of 1 degree temperature difference through 1 square meter of glass area. That is my U value. So say if I have 1 degree temperature outside and inside is 0 degree temperature. So because of this 1 degree temperature difference, whatever heat is transferring from 1 square meter of glass area, that is my U value. Okay. Now we will see that what will be the impact of SHGC and U value on the building. That what will be the impact, how it will affect your glass selection. So for that, what we have to do, we have to find the total heat gain. Total heat gain is what? It's a summation or addition of direct heat gain plus indirect heat gain. Now direct heat gain is because of SHGC and indirect heat gain is because of U value. Direct heat gain is because of SHGC. Why? Because it is directly related to the solar radiation. This particular heat is directly coming from the sun. And U value heat, we call it indirect heat because it depends on the temperature difference. It is coming indirectly. If you do not have the temperature difference, this particular heat will not transfer, right? That is why we call it indirect heat. So what you have to do, you just find total heat, direct heat gain and total indirect heat gain, and then you add it. Okay. Now, how to find total direct heat gain? For that, you have to multiply the SHGC or the solar factor of the glass with incident solar energy. Now, incident solar energy is what? It is a intensity of the sun at a particular location. Say if I talk about Mumbai, my incident solar energy might be different from Chennai. It will be different from Kolkata. It will be different from Shimla, right? So, say Mumbai, Chennai, Kolkata, I might have higher incident solar energy, where Shimla, Manali, I might have incident solar energy lesser. Okay, so it depends on the location. You just multiply it with the SHGC of the glass. You will get the total direct heat per square meter. Okay, and total indirect heat, you just multiply whatever temperature difference you have inside and outside with the U value of glass. Okay, I'll give you one example. You can have the better idea here. And it will again tell you why SHGC or solar factor is important. So now you can see I have taken one example where solar incident energy is 630 watt. Okay, and temperature difference I have taken 15 degree, right? Now you can see SHGC of the glass I have taken 0.3 and U value of the glass I have taken 3. Okay, now DHG is direct heat gain and IHG is indirect heat gain. So if I have to calculate DHG, what I will do, I will just multiply solar factor with solar incident energy. 0.3 into 630, which will give me 189. And U value of the glass, I will multiply with the with the temperature difference, which will give me 3 into 15, 45, right? And when I add both of them, it will give me total heat gain, DHG plus IHG. 189 plus 45, it will give me 234. So you can see here, this 80%, this 189 watt is 80% of my total heat. If you take out the 80% of 234, it will come near to 189. 80% is contributed by solar factor and only 20 to 25% is contributed by U value. So this is the main reason why in India SHGC is more important, because India is a tropical country and we have so much solar radiation, and temperature difference will not be much. If you say I am at a particular location where temperature is 50 degree. I am at the Nagpur and my temperature is 50 degree, and inside I want to maintain 25, and still it will be maximum 25-degree temperature difference, right? But your solar incident energy, it is in the hundreds. When you multiply it, it will give you the higher value. So this is the reason in India why solar factor matters more than U value. Okay. Fourth parameter of the glass, we have internal reflection. So internal reflection is what? I'll give you one example. During the night time, what happens when you look out of the window, you see your own image, right? You won't be able to see properly outside. You are seeing your own reflection. So this is what we call internal reflection. That when you are trying to look outside from inside and when you see your own image, internal reflection of the glass is high. But if you are able to see properly outside, internal reflection of the glass will be low. Again, external reflection. Same thing as internal reflection, but when you are outside the building and when you are trying to look inside. Okay, if you are seeing your own image on the facade, it means that external reflection of the glass is high. But if you see properly inside, external reflection of the glass will be low. Okay, so now you can have the question that internal reflection should be higher or lower, external reflection should be higher or lower. SHGC should be higher or lower, U value should be higher or lower, VLT should be higher or lower, right? So for VLT, I will tell you. VLT, you need to have optimum, not higher, not lower. It depends on so many parameters that we need to do the daylight simulation, and then we can tell you that what is the optimum VLT for the particular project. Solar factor, again, it should be lower, right? As low as possible. U value, lower the better. Internal reflection, always it should be lower because you want to see clearly outside. And external reflection, it depends again on the project. Say if you have the private or the government project where they do not want outside people to see inside, right? In that particular case, they will go with the higher external reflection of the glass. But say it is a mall project or a showroom where people want to showcase their product, they will go with the lower external reflection of the glass because they want to showcase their product, right? So this was about the basic of the glass and the basic property of the glass, and this is all the different application and different type of the glass. Okay, thank you. छोड़ हमारा जरा close up 2 minutes छोड़. No, what should I do? I'm not aware. Hello, hello, hello. Okay, so now if you have any question, you can ask me. Whatever question you have, I think there was some issue in the synchronization. So if you have any issue, you can ask me. Hello? 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 Hello, any question? Hello, any question? Yes, fire resistant glazing can act as a structural glazing. You can use it. Hello, any question? You can reduce the glare by putting blind or by putting shades or shutters. Passive illumination is what you can do it with the design or choice of the material. You can actually select a material which will give you the optimum light, which will reduce your glare problem. So these are some of the example of the active illumination that you can put the blind or you can put the expensive shading devices or you can reduce the glazing area. This is the active elimination of the glare. And second, like passive elimination of the glare is choice of material. You can actually go with the tinted glass or optimum VLT glass, which will absorb a large fraction of incoming solar radiation and glare, thereby reducing the solar heat gain coefficient, and also will give you the optimum VLT. And second is you can do the ceramic fitting. It will diffuse the light and eliminate the glare. Again, the third choice in the passive elimination is the dynamic glass, which I mentioned in the starting of our presentation, that what is a dynamic glass. You can actually change the tint of the glass based on your requirement. So that is an also option. And also you can go with the tinted glass, that you can actually go with a glass on green or a blue substrate, right? Now you might have the question that what if we are going with the tinted substrate? From inside, when we are trying to look outside, we can see that there is a greenish tint or a bluish tint, right? We won't be able to see properly. No, it won't be a case. You can see here, this is one example. This is one project and where we have used KT440 product. Now KT440 product is a green color product. So from outside, definitely it will look green because you have selected a material green, right? But from inside, you can see it will look as clear as possible. You will not even feel that I have put the green substrate of the glass, right? Again, second example, you might think, what if we have the white interior? The reflection would be green or blue, whatever substrate we are using. But no, again, you can see KT440 product, green color product, but from inside you can see it is as clear as possible. Even if you have the white interior, the reflection won't be green or blue. So this was about the VLT. Now we have the solar factor. So solar energy incident on the glass is partly transmitted, as you can see here, partly reflected and balance absorbed. Okay, the solar energy absorbed is re-emitted inside and outside again. So the total solar heat gain is direct solar radiation plus solar radiation absorbed and re-emitted inside, divided by the total heat which was being incident. This is known as a solar factor. Okay. So you can see here, which I have circle here, that is my total heat coming inside. Okay, you add both of the heat and divide it with the incident solar radiation here. You will get the solar factor. You will get the ratio which is called the solar factor or SHGC, solar heat gain coefficient, or G value. Then we have the U value. The third parameter of the class is U value. U value is what? You just have to remember the unit of U value, watt per square meter Kelvin. Then you can easily remember the definition of the U value, watt per square meter of Kelvin. What does it indicate? Total amount of heat coming inside because of 1 degree temperature difference through 1 square meter of glass area. That is my U value. Okay. Again, I will repeat. U value is total heat coming inside because of 1 degree temperature difference through 1 square meter of glass area. That is my U value. So say if I have 1 degree temperature outside and inside is 0 degree temperature. So because of this 1 degree temperature difference, whatever heat is transferring from 1 square meter of glass area, that is my U value. Okay. Now we will see that what will be the impact of SHGC and U value on the building. That what will be the impact, how it will affect your glass selection. So for that, what we have to do, we have to find the total heat gain. Total heat gain is what? It's a summation or addition of direct heat gain plus indirect heat gain. Now direct heat gain is because of SHGC and indirect heat gain is because of U value. Direct heat gain is because of SHGC. Why? Because it is directly related to the solar radiation. This particular heat is directly coming from the sun. And U value heat, we call it indirect heat because it depends on the temperature difference. It is coming indirectly. If you do not have the temperature difference, this particular heat will not transfer, right? That is why we call it indirect heat. So what you have to do, you just find total heat, direct heat gain and total indirect heat gain, and then you add it. Okay. Now, how to find total direct heat gain? For that, you have to multiply the SHGC or the solar factor of the glass with incident solar energy. Now, incident solar energy is what? It is a intensity of the sun at a particular location. Say if I talk about Mumbai, my incident solar energy might be different from Chennai. It will be different from Kolkata. It will be different from Shimla, right? So, say Mumbai, Chennai, Kolkata, I might have higher incident solar energy, where Shimla, Manali, I might have incident solar energy lesser. Okay, it depends on the location. You just multiply it with the SHGC of the glass. You will get the total direct heat per square meter. Okay, and total indirect heat, you just multiply whatever temperature difference you have inside and outside with the U value of glass. Okay, I'll give you one example. You can have the better idea here. And it will again tell you why SHGC or solar factor is important. So now you can see I have taken one example where solar incident energy is 630 watt. Okay, and temperature difference I have taken 15 degree, right? Now you can see SHGC of the glass I have taken 0.3 and U value of the glass I have taken 3. Okay. Now DHG is direct heat gain and IHG is indirect heat gain. So if I have to calculate DHG, what I will do, I will just multiply solar factor with solar incident energy. 0.3 into 630, which will give me 189. And U value of the glass, I will multiply with the solar with the temperature difference, which will give me 3 into 15, 45, right? And when I add both of them, it will give me total heat gain, DHG plus IHG. 189 plus 45, it will give me 234. So you can see here, this 80%, this 189 watt is 80% of my total heat. If you take out the 80% of 234, it will come near to 189. 80% is contributed by solar factor and only 20 to 25% is contributed by U value. So this is the main reason why in India SHGC is more important, because India is a tropical country and we have so much solar radiation, and temperature difference will not be much. If you say I am at a particular location where temperature is 50 degree, I am at the Nagpur and my temperature is 50 degree, and inside I want to maintain 25, and still it will be maximum 25-degree temperature difference, right? But your solar incident energy, it is in the hundreds. When you lower, the better. Internal reflection, always it should be lower because you want to see clearly outside. And external reflection, it depends again on the project. Say if you have the private or the government project where they do not want outside people to see inside, right? In that particular case, they will go with the higher external reflection of the glass. But say it is a mall project or a showroom where people want to showcase their product, they will go with the lower external reflection of the glass because they want to showcase their product, right? So this was about the basic of the glass and the basic property of the glass, and we also saw the different application and different type of the glass. Okay, thank you. Okay, welcome back. So now we have the next topic, high performance glazing and the glass in the green building. That how this high performance glazing and how this high performance glass will help you in the green building rating system. How you can get the point through it. So first we have what is high performance glazing. How you can achieve it. So basically, high performance glazing is nothing but the parameters which I mentioned earlier during the presentation, like VLT, solar factor, U value, and reflection, these parameters you want at a certain level. That I want more VLT or lower VLT. I want to lower SHGC. I want lower U value. I want high reflection. I want lower reflection. So all that parameter, whatever you want, you can get it. And how you can get it? How you can achieve that kind of performance which you desire? So you can get it by doing a coating. The answer to this particular question is coating. You have to do the certain kind of coating to attain a certain kind of parameter. Okay. So there are two type of coating system, two type of coating process, as I mentioned earlier during the starting of the presentation. First is online coating, second is offline coating. So in online coating, what we do the coating itself while the glass is being manufactured. Okay, when you make the glass, at the same time you are doing the coating, and we call this process a pyrolysis process. The second is offline coating. Here in offline coating, we do the magnetron sputtering coating. In this offline coating, the coating is done in the different plant called a coater plant. Okay, here what we do, we make the raw glass, we put it in the storage, and again we take it to the coater plant and we do the coating. Okay, so basically, this is how the coating will look. This particular coating will be very thin. The coating which we are doing on the glass, it is very thin. You will not be able to see with the naked eye. Okay, this will be in the range of nanometers. So this is how the coating will look when you look into the CS. So online coating and offline coating. In online coating, there are some limitation, and in offline coating, there are some advantages. Okay. In online coating, it was a first coating technology when the coating was something like that was invented. Okay. It had a limited performance. You cannot all the performance which you desire. Then it had the limited aesthetic option. You cannot get all the aesthetic option which you want. But in offline coating, all these problems were solved. You can get the superior energy performance, whatever high performance you required in the glass, you can achieve it. Then you have the limitless option in the when it comes to the aesthetic, and these products are temperable product. You can temper these kind of product. Okay. So here on the right side, you can see 1G, 2G, 3G, 4G, 5G, and okay, so this G is generation. There are different generations of product. The first generation, 1G, was reflectosol. This product was called reflectosol product, and it was online coated product. Then from second generation, whatever you are seeing, 2G, 3G, 4G, 5G, and 6G, these are the offline coated product. Okay, so now there must be something different in all this generation of product. Those are offline coated, but what is the difference in that then now? Okay, so on the right side you can see there is one arrow called spectral selectivity. So this is a difference in all this generation of product, that spectral selectivity is increasing when you go to sixth generation from the second generation. Now what is the spectral selectivity? Spectral selectivity, it is nothing but a ratio of light to heat. Okay, what light you are getting from the glass divided by what heat you are getting from the glass. That ratio, when you take out that ratio is called the spectral selectivity. Basically, you need high light to come inside, more light to come inside, but at the same time, you do not want heat to come inside, right? So this is a difference in all this generation of product, that your spectral selectivity is increasing. You are getting more light, but at the same time, you are getting less amount of heat. Now, why this evolution of product? Why this evolution of generation? What was the need of it? Okay, so these products have been made sensing the need of the market. Okay, why? Because earlier in generations of product, we had low solar factor, I mean medium solar factor and medium U value, but people wanted more lower solar factor and more lower U value. Then we moved to third generation. Now at the same time, solar factor and U value were reduced, okay, but at the same time, people wanted high light to come inside. Heat, they want less only, but they want light to come inside. So fourth generation was invented. Then fifth generation, more light, less heat. Sixth generation, more light, less heat. Like that, all this product generation we had. From here, fourth generation, fifth generation, and sixth generation product. Why we are getting better performance here? Why we are getting more selectivity here? Because all these are silver coated product. What is a silver? As I mentioned, that we do some kind of coating on the glass to get certain properties, right? So from those, and there won't be a single layer of coating. There will be multiple layer of coating. Okay. So say we have 50 layers of coating or 80 layers of coating. From those 50 or 80 layers, in fourth generation, one layer will be of silver. In fifth generation, it is a double silver product, so two layers will be of silver. And sixth generation is a triple silver product. You will have three layers of silver, and because of that, you are getting a higher performance here. Okay. So this is one comparison of the product, so you will understand why a certain generation is better than the other generation. So you can see here I have taken one product from each of the generations, second, fourth, fifth and sixth. And when you see the VLT column, you can see VLT is approximately same for all the generation of product, 47, 50, 46. Okay. But if you see the solar factor column, from the second generation to the sixth generation, that solar factor is reducing drastically. So what I am trying to say is, for the same amount of VLT, you are getting very reduced solar factor in sixth generation of product. I am getting same VLT, but I am getting only 22% of direct heat coming inside in sixth generation. I am getting same VLT, which is 50%, but I am getting 28% of heat to come inside in the fifth generation. Like that, in the second generation, I am for the same VLT, I am getting 47% of heat to come inside. So you can see here, when you go from the lower generation of product to higher generation of product, your selectivity is increasing. That ratio you can see here, VLT to solar factor ratio will increase. And that is why we call it a better generation product, high performance product, highly selective coating and highly selective product. So when you have lower SHGC and lower U value, you will have a better thermal comfort and energy efficiency, which will eventually help you get the energy efficiency point in the green rating system. Okay, so now we will see that how this high performance glazing will help you get the point in green rating, and what is green rating, what is green building, and everything. Okay. So basically, these are some data that today, nowadays, building sector is consuming a lot of resources. All energy use is approximately 25 to 40%. Then greenhouse emission is around 30 to 40%. All water consumption 20%. Solid waste stream approximately 30 to 40%. And this needs to be reduced when it comes to the building sector. So how can we do it? What are the ways to do it? So we can do it by moving to the path of sustainability habitat. Okay, sustainable habitat. We should keep these points in our mind, which are energy efficiency, comfort, health, and preservation of the environment in our mind when we are going with a certain building design. We have to keep these things in our mind to make our building a green building and to make the environment preserved. So what is this green building? When you want to save the environment, you want your building to be energy efficient, so you are going for the green building, right? But what is this green building? So basically, green building is a kind of design or a construction or a operation which will reduce or eliminate the negative impact, and it will produce a positive impact on our climate and natural environment. Buildings are going to be built, there is no doubt in that, right? But we can do it in a sustainable way. We can save our environment by going for the green building. Okay. So now how you can get how you can make your building a green building? So basically, for that you need to follow certain green building rating system. So why green building rating system? Because they are kind of a guide, okay, which can guide you in terms of green building, that what you have to do to get your building certified as a green building. Okay, they have certain rules, they have certain performance criteria in terms of design and construction and operation of the green building. So in a normal simple language, it's a kind of guide which will help you to create a green building. Okay. So in India, basically, widely we have three green rating systems which generally people are following. One is LEED, Leadership in Energy and Environmental Design. Then we have IGBC, Indian Green Building Council, and then we have GRIHA, Green Rating for Integrated Habitat Assessment. Basically, these are the three green rating systems. And in addition to that, we have also ECBC, Energy Consumption Building Code, and the NBC, National Building Code, which are kind of a guide which will give you a guideline in terms of energy consumption. Okay. Okay. So when we talk about the green building, when we are going with the green building, there are certain criteria in each of the green building rating system which you need to follow. You just need to think that when you are going to construct a green building, when you are going to construct any building, what are the resources you are using? You are using site, you are using land, you are using water, right? You are using electricity, you are using certain material, right? So all those things should be done in a sustainable way, and that is what a green rating system is telling you to do. Okay. So basically, they have divided all these resources and all this parameter in a certain category. Okay. So first is sustainable architecture and design. Second is site selection and planning. Third is water conservation. And then we have energy efficiency, then building material and resources, then indoor environmental quality, and then we have innovation and development. Okay. So these are basically main category in green building rating system. Say you are using certain amount of water while building your building, right? So that you have to do in a sustainable way. Now, how you can do it? For that, they have given a guideline. Now, again, you want your building to make energy efficient, right? Definitely. How you can do it? They have given a guideline. You are definitely you are going to consume certain material when you are trying to build your building, right? How you can do that? How what kind of material you can use? For that, they have given a guideline like that. So, green building are the kind of guideline which will help you create a green building. So first we will see lead, lead green rating. Okay. So total point in lead which you can get is approximately 110 point, and they have divided each of the category. Like if you get a total point of say 60, your building is considered in a gold rated building. Okay. Then if your point is more than 80, your building is considered to be a platinum rated. Like that, they have bifurcated it. So as I mentioned, these are the basic category in the lead location.